G'day, I'm Tim Thompson. Are you fascinated by how things are made and how things work? Well, a little while ago, I had the tremendous opportunity to go up and meet with Matt, who's the factory manager at White's Rural, where they manufacture not only barbed wire, hinge joint, stiffstay, but a whole range of fencing products. This week's video shows you exactly how they do it. I was like a kid in a lolly shop, and I'm sure if you like how things are made, this week's video will be for you. As always, if you like this video, please do hit the little subscribe button, give it a thumbs up. Now let's go and enjoy watching how fencing products are made in regional Australia. So welcome to Albury, Wodonga. Just below 100,000 people live here, nestled on the Murray River, halfway between Sydney and Melbourne. It's here that White's manufactures its fencing wire. Matt, I'm really excited to be here today.
Yeah.
Thank you very much.
Yeah, pleasure.
You're going to have a lot of really interesting things to discuss with us over the next quarter of an hour or so.
Yeah, for sure. We've got a lot to show. We're at our stiffstay machine where we manufacture our stiffstay products. This machine is a fairly large machine, and we can do about 20 kilometres of fencing per 10-hour shift. So it's a big, fast machine that uses plenty of wire. So this machine can run at 80 beats a minute, 2 fences at once, has a multitude of different setups, so we can basically tailor a fence to what we need.
And because this machine is computer operated and totally electronic almost,
yes,
you can actually run not only 2 fences at once, but 2 different fences at the same time.
Yeah, definitely. So, it's very programmable compared to some of the old machines that make prefab fencing. So we can run 2 fences at once, we can run a fence with a hinge footer. So there's lots of different options with this machine. And this machine's always kept busy because of that.
So Matt, the stiffstay machine's operating now, and you're making 2 types of fence at the same time?
Yep. We're making a 790/30 200 metres and an 890/30 200 metre coils, both at one time.
So because the machine's computer controlled, you can do 2 jobs at once?
Yeah, that's exactly
on the
right.
one bed?
Yeah, that's right. So which is fantastic. We're currently running 27 1-ton stems feeding that fence.
Yep, and once again you've got different types of wire for different sections of the fence?
Yeah, so the knot wire is different to the line wire. The line wire is a higher tensile, the knot wire is a soft tensile. Yep. The stay wire is a medium tensile.
Yeah, right. And pardon me, but it looks like hell's knitting machine, doesn't it?
Yeah, it does.
It's a pretty impressive piece of kit.
It is, yeah. And when you have a more complex fence in, there's more wire feeding it again. So
right.
It can get
so what's the
complex.
maximum number of stems that you'll be feeding into that machine?
I think you can get up to 38. So,
right.
Yeah. So
and you've got 27 going in at the moment. It's a pretty impressive layout, isn't it?
Yeah, it is. Yeah. And each one of those stems can get changed up to 1 time a shift, depending on the fence that you're running. So it can be quite busy changing stems at times.
I can imagine. So we've got the main controller of the machine just here, Matt?
Yeah, that's right. Yeah, so we have a touch screen that we can set the parameters of the fence we want to build. So we set all that up, get the machine running, and this will also show us any faults. When a sensor gets tripped, it'll tell us where to look for the problem.
And you've got about 50 of those, is that right?
50 sensors on the machine, so
that's incredible.
If you have a line wire break or a knot wire fault, at least it'll trigger that sensor, and we know where to look, to go and fix the problem. It tells you how fast we're running, so we're currently running 70 beats a minute.
And that's going to crank out about how many kilometres of wire today, do you think?
Yeah, we'll probably do about 20 kilometres today of wire.
Yeah, right.
Which is a fair whack of wire in one day.
I can imagine. Yeah. And we've got our knot tying down here.
That's right. So
this is a special knot. This is the stiffstay knot.
Yep, stiffstay knot. Stay wire coming across the line wires, and the knot gets formed around that. And it goes up to the crimp drum it's called, which as it rolls over the top there, it gets the tension crimp put into the line wires.
And there's less tension crimp in these fences than there are in ring lock?
In hinge joint, yeah, exactly. Ring lock and hinge joint, so the stiffstay has less because the stiffstay is more adjustable. We can put the picket wires very close together, so we can't afford to have too big a tension crimp when the picket wires are really close together.
And I suppose because these knot tying blocks are so small, you can actually bring them right close in together and you can run a whole heap of line wires.
Yeah, exactly right.
So some of these sensors, mate, they're just to let you know that you've run out of wire.
Yeah, exactly.
So we've got a sensor out here.
We've got an orange light here, so we know there's a fault in the back frame somewhere. And and we can look over, we can see the red flashing light down to the stem of wire, and we can see we've run out of wire. So now we'll change that in, put a new stem in, join it and run it through, go again.
I believe that you've got some other stuff to show us,
Yep,
like
we've got
barbed wire and your
barbed
chain
wire,
mesh fencing, all sorts of things.
chain link, hinge joint, some weld mesh products.
Oh, I can't wait, let's go. Right, so we've got two types of barbed wire that you guys do here as well, Matt. You do the high tensile and you do the Iowa barb.
Yep, correct.
And we're about to see how they're made. So we've got your 1 tonne bales of wire here. At the moment you're doing a 1.5 mil high tensile wire that's woven.
Yep.
And then you've got your softer barbed wire in between.
Yeah, so basically the product's made up of two different types of wire. The line wires are 1.57 high tensile and the barbs are a 147 soft wire. We'll go over and watch how they're all tied together.
So what exactly is happening here, Matt? Can you talk us through it a little bit, please?
Yeah, sure. The machine, so I can show you how it works. I'll just lift the guard and we can cycle it through slowly and you'll get a better view of how it all works. Okay, so we've got the line wires coming in here through the straighteners. This is a reverse twist machine, so this is the twister that grabs the two line wires and twists them. And then this is where the barbs we put on, where the twister's been placed.
So with high tensile barb, there's an opposing twist, isn't there, Matt?
That's right, so it's a reverse twist, so it gets clamped here and here, and then the twister, you can see it twist in it, so it'll twist one way and then the other. And then it'll come through the machine, and this is where the barbs are placed onto the line wires.
I don't think I've ever seen anything quite so satisfying in my life as watching those twists come on and get cut off. That is fantastic. Now the barb is finished, and there's a barb. How far apart are the barbs on this?
Yeah, so they're 100 mil as per Australian standards. And then they'll go through these compensator wheels and then go onto the wooden spool, and we can show you how that works.
And then the machine really does lull you into a sense of false security with the guard open while it's in its maintenance setting and it's just cycling through slowly. When Matt puts the guard down and cranks her up, it's a whole different ball game. And once again, you can see those barbs are fair flying onto that wire once we get the machine up and running at full stream.
Once it leaves the compensator wheels, it comes up and it gets wound onto the wood reel, which is unique to Australia really. And it's layered and it also has back tension on it to get our rolls nice and tight. I'll just show you how that works.
So this is a feeding mechanism much like you'd see in a lathe, isn't it? We've got the
That's right, to layer it.
We've got the layering happening. And of course when the guard's closed and we're not running the machine on a caution setting, this is fair flying.
Yes, absolutely.
How many kilometres would you be doing every day of this?
Well, probably about 20 on this machine.
And so here's some of today's production.
Yeah, some of the product, so it's ready for labelling. It's got another layer to go on that pallet and then it'll get ready to go.
Okay, so that's high tensile wire.
Yep.
Now we're on to Iowa barb. Now there's a bit of a difference.
Yep, so the line wires are a soft wire with Iowa barb, 2.5 millimetre in this case. And also it's a continuous twist, so it's not a reverse twist, it's just one twist the whole way along the roll. So,
and the barb is inserted through?
Between the two line wires, exactly, and then twisted. So we'll have a look and we'll see if we can see in the machine running. The line wires are getting fed through and the barb is being fed between them, and the barb twist has happened and the shears are cutting the barbs off at the right length. And now it's going through the compensator wheels and then it'll go all the way down the bottom, back up, and then it'll actually be on the wood spool, and the wood spool is also being twisted at the same time as it's being wrapped, which creates the twist in the line wires.
So this is manufacturing Iowa barb is a much more continuous process than it is with high tensile.
It runs about the same speed, but yeah, that's right, it's a continuous twist, so the thing is continually twisting. So there's less moving parts in this machine, hence to be quieter.
And some of the advantages, I suppose, of having the high tensile barb is just simply the line pull strength now that you can get.
Yeah, less elasticity in the wire, so you can pull it up nice and tight, it stays tight. And then Iowa's a bit more stretchy, being a soft wire.
Yep. This is the stuff you've got to be careful when you strain up because it can come back and bite you.
It can do, yeah, absolutely. Every time it counts, that's one barb, so that's 100 mil as well. So that's how fast the machine's running.
So a 500 metre roll, 5,000 barbs.
Yeah, exactly. be 400 metres being Iowa.
So that's part of your quality control as well, as making sure that there are that
Got the
number of
length,
bars.
yeah, exactly.
Now, in terms of fabricated mesh, Hinge Joint was one of the earlier types of fabricated mesh that were around, and you guys have been doing that for a fair while.
Yeah, we've done about 11 years now on the Hinge Joint machine, and we bought a machine new from New Zealand, so yeah, we'll go and have a look at it. Okay, so we've currently got the machine running on 890/15. So the Hinge Joint machine can run up to about 120 beats a minute on this product. As you can see, it's a very mechanical machine, so it's quite limited in its adjustment compared to, say, a stiffstay machine. It can do about 8 different products without too much customization. And as you can see now, we can sort of work our way through what's happening here. So now here you can see the machine running. The line wires are coming up vertically, and the horizontals are the stay wires being twisted onto the line wires. Once again, this machine, you need a different tensile wire for the picket wire versus the line wire. And the compensator's pulling the wire through after the knots are formed, and it's going over to the crimp drum to have the tension crimps put in the line wires. So Matt, we're just running the machine slowly now so that we can see a close-up of what's happening here. So we've got our picket wire being fed in, and each picket wire is individual between each line wire, and they're being fed in, cut and twisted all at once by that little cam. So I can see what you mean here about the limited range of options that you have, because you're limited by the actual width of the machine and the cutting blades, aren't you? Yeah, and the twisters, you can't move the twisters along the bed, so they're set in one spot. So all you do is put the line wires where you want to make the fence that you want.
So even though this is still a good option for many people, if people want customisable fences and flexibility, you've had to invest in whole new machines for this.
The stiffstay is really coming to its own in that market for sure.
And it looks like it's going to be the way of the future.
Yeah, like sales in stiffstay are certainly ramping up very quickly compared to Hinge Joint.
Yeah. So Matt, now we're going to have a look at making gate mats. You guys not only manufacture the pipe work of gates, but you also manufacture the mesh inside them. And so for that we need to get the 1.5 tonne rolls of wire, you need to straighten it, you need to cut it to length, and you need to weld mesh it.
Yes, that's right. Yeah, so we've got the wire straightened here. So this is prepping the wire for the weld mesh machine to weld it together. So this machine basically decoils wire off 1 tonne stems, straightens it and cuts it to length. Okay, so once the wire's been prepared, it's been straightened and cut, now it comes across to the machine that welds it together to produce the weld mesh. See here we call these the line wires. They're on the bed ready to be fed into the machine. And then we have the picket wires on top of the machine, which are automatically dropped on top of the line wires. And then the machine will weld them together. This machine can do multitudes of products. We use it for our gate mats, sheep yard mesh and tree guards. So this machine uses a lot of energy. So it has a big water cooling tower, and you have to warm the machine up a little bit before we get it going.
And you guys have been doing some interesting stuff with your energy consumption, haven't you?
Yeah,
I noticed when I came in, a lot of solar panels on that roof.
Yes,
Can you tell me a little bit about that and whether it's possible to actually be sustainable in manufacturing?
Oh yeah, sure. So our energy bills were getting fairly large, pre-solar. So we had to look at solar and LED lighting, and we've invested in 200 kilowatts of solar and LED lighting through the place to try and make our energy bills a little bit more user-friendly. Look, we put a data logger on the power station and logged it for a month, and like on a nice bright sunny day, we pretty much use 100% of our solar power. We don't put any back in the grid, so that means we're using full power from the solar.
But you're also running most of your machines on energy from the sun.
Yes, correct, yeah.
Which is a huge thing for sustainability.
Yeah, absolutely. And as when battery technology gets better, you know, that's our next step.
So
Yeah.
to actually store it, weekends and things like that when you're not running, you can then feed it back in. Because I imagine when you get machines like this up and running, you probably do go back onto grid supply a little bit.
Oh, very much so, yeah.
So what percentage do you think of your power consumption that you're using now?
Well, we can, that's what I mean, like on a bright sunny day, we can be down to nearly 95% solar power usage and 5% off the grid.
That is absolutely unbelievable.
Yeah,
it's not only good for your bottom line, it's good for all of us.
Oh, it's good for everyone, yeah, that's right.
Brilliant.
Yeah, it's a good sales pitch for solar. Yeah.
Absolutely. So Matt, you guys also manufacture chain mesh as well?
Yeah, so that's our oldest machine, and it's the first wire machine we ever bought many years ago. So yeah, chain link fencing. So this machine at the moment is currently running a galvanised 2.5mm soft wire. It can do plastic padded wire as well, and we can do a heavier gauge wire as well. The machine can go anywhere from 300mm wide up to 3.6 metres wide.
Okay.
And we can basically do about 100 metres an hour, roughly.
I imagine there'd be a fair bit of skill in setting this machine up.
Yeah, that's right. Yeah,
you have one of your most experienced operators on it?
Yeah, we do, and it takes an operator a good few months to get his head around running it efficiently. Yeah.
So this is really going back to the days when there was art in manufacturing, isn't it?
Definitely. There's a bit of black magic on this one.
Yeah.
That's right.
Isn't that awesome to see technology and investment occurring in our regional communities, building great products for us all to use? I hope you enjoyed this week's video, guys, and if you did, smash that subscribe button, hit the like, and I'll see you next week for more.